let's get this started. Well, I hope everyone's like feeling comfortable, like not too tired, like on your last, basically slot session of KubeCon. Well, thank you for choosing to be here. Like, I know it's somewhat of a stretch after like these days, and well, thank you for choosing our talk when there's actually other like 2 simultaneous like authorization talks going like on others. So, by the way, this is your cue. If you just realize you're in the wrong one, like, just saying. So my name is Guerreiro, but actually everyone calls me Joe, so call me Joe. I work at Grafana for the identity and access team. We actually provide like a application platform for other teams to build features on. So let's say like having like the authorization checks, like having like resources that are like instrumented, so let's say protected with RBAC. And actually our journey kind of starts like in 2024 at KubeCon in Paris. There we saw a presentation about OpenFGA. We actually were really excited and we contacted the OpenFGA team afterwards. Like they were great. Like we were like really excited to get like an integration or like a partial migration going. But after this like initial excitement, we noticed that like something was missing. We couldn't find a lot of like real-world examples of moving multi-tenant systems like ours on cloud to OpenFGA. And well, there's a lot of examples like for new projects and even for, like for new multi-tenant projects. And if you are starting like a new project, in that case, save yourself the trouble and like start integrating like with a like access control engine like from the start. But on our side, we have a lot of like legacy, like let's say baggage, like almost like 14 years of access control features. And so we wanted to know like how are other people like handling this transition. So this is a bit what we want to share today, and hopefully answer like questions like that you have, like, well, would OpenFGA fit my use case? Like, what hurdles might I expect like in this migration? And I think to start, like the best thing is to give it over to Poovamraj.
Hey all, I'm Poovamraj Thanganadar Thiagarajan. I'm the technical lead in the FGA team. We do everything from integrating OpenFGA into CM platforms, identity platforms, and observability. And yeah, let's get into the presentation. If you start a new project today, would you build a login for it from scratch? There are so many great libraries, frameworks, and services out there that we don't need to build this ourselves. We all know of protocols like OpenID Connect, OAuth 2, and SAML that we can adopt based on the need. But imagine authorization. Each product builds their own authorization. There is no standard we usually adopt. Sometimes even within the same product, each service does authorization differently. This is a problem right now. We as an industry don't have a good solution for authorization. Still not convinced? Check out the OWASP top 10 list. First in the OWASP list, and 3 of the top 10 in the OWASP API list are authorization related. So why is authorization a hard problem? The requirements of authorization can be granular. And to be honest, it's so diverse and really depends on the application. We don't want each service to create its own authorization. This leads to silos, specialized patterns, and both knowledge and security gaps. There is no standardized way of solving it. Every time you start at a new company, the way you do authorization changes along with it. Let's go on a tangent to a few decades ago. Let's look at a similar problem we had as an industry in the past. Data storage. Before relational model existed, application used custom logic on how data was stored and accessed. This caused tight coupling, redundancy, and in solving the same problem, it caused inconsistency due to lack of standardization. There were some attempts of standardization, like network model, hierarchical model, but they never took off. This was until relational model was introduced. We found the right abstraction to access our data that fit for 90% of our use case that we never looked back. Similarly, we need the right abstraction for authorization. That's the search we are in now. Google, in search of that right abstraction, released a white paper in 2019 called Zanzibar, Google's Consistent Global Authorization System. In their paper, they explain how their system solves all the problems we have as an industry. Need an authorization system that's generic for all applications? Hundreds of client services at Google, including Calendar, Cloud, Drive, Maps, Photos, and YouTube, uses Zanzibar. You can see that it can adapt to various needs of different applications. Need a centralized system? Zanzibar is useful for building common infrastructure on top of unified access control system. It provides, in particular, a search index that respects access control and works across application. Please note the search index part of it. We will come back to it later in the presentation, but search in and itself is a hard problem, but try solving it along with authorization, it becomes even harder. No standardization. To solve that, Zanzibar provides a uniform data model and a configuration language for expressing a wide range of access control policies. This led us to build OpenFGA. OpenFGA is an authorization inspired by Google's Zanzibar. It's a modular authorization system which makes it easier for teams with hundreds or thousands of developers to manage their authorization system centrally and, most importantly, uniformly. We are a CNCF sandbox project. We are at KubeCon. It should go without saying we provide first-class support for Kubernetes. And yeah, now that you know a bit about OpenFGA, let me show you the power of a declarative authorization by showing how OpenFGA works. We as an industry always loved declarative code, much more than imperative. Raise your hands if any of you use at least one of these technologies. SQL, Kubernetes manifest, Terraform, or React. I'm sure every one of you, yeah, all the hands are up here. We do love declarative way of doing things. All of these technologies are declarative, and they're loved by the industry. So let me show you how you can achieve the same thing with your authorization system as well. This is a representative example of how Grafana's system works. In the model shown here, you can see different entities. It has a user and teams, which are identities. It has folders and dashboards, which are resources. Here you can see we are associating different entities with each other. For example, a user can be associated to a team. A folder can have a parent folder. In the same way, a dashboard can be present inside of a parent folder. Now that we've represented the entities, let's add an authorization role to it, an admin. We are associating a user to be an admin of a folder. These associations can be even more expressive. As you can see here, a user can be a viewer, right? Pretty straightforward. But you can also assign all the members of a team can be a viewer. Think how powerful this is. Next time you add someone to your team, they will automatically be able to view the folder. Or if you want to make a dashboard public, you can set something like user star, and anyone will be able to view the folder. We call this wildcard. Now that you've added all the information to FGA, the interesting part starts. Let's say you want to add a permission where only admins can create a dashboard inside a folder. You can simply do that by adding this line to your model. You can start adding any number of permissions in a similar way. But you could ask me, hey, isn't this RBAC? Nope. Because you are assigning a fine-grained permission of a user to a folder, FGA thinks of how a user is associated to a particular object. It doesn't stop at assigning a particular role to a user. Now, you might want even more expressiveness to represent your authorization system. You can use algebraic operations. You can add operations to denote unions, intersections, and even negations. Here, you're declaring that a viewer can be anyone who is assigned to it, or anyone who is the admin of the folder can automatically be a viewer. This means all admins of a folder automatically become a viewer of the folder. But you could ask me, you want even more expressiveness, you can represent even inheritance by saying any viewer of the parent folder can be viewer of the child as well. Imagine how powerful this is. The inheritance can span multiple levels, allowing you to represent even complex authorization use case. It can be like, you can go to users, teams, organizations, companies, guest users. Your imagination is the limit to represent your authorization system here. And that is it. Think of how many lines you would need to implement a system, an authorization system similar to this. Now, hoping that I've convinced all of you the powers of OpenFGA, let me hand it over to Joe to go through Grafana's experience of migrating to OpenFGA. Thank you.
And so, well, now it's the time that I burst Poovamraj's bubble, with now let's go with reality and what we've seen. So our team actually doesn't attend a lot of conferences like other Grafana teams that you see. So actually, I hope that you find this small look inside of Grafana's internals interesting. So on your side, if you want to move to OpenFGA, the first thing you need is actually the need. You actually need to this type of features. And for this, I'm going to show a bit of the beginning of Grafana, which is Grafana started as a single monolith. Everything was tightly integrated. Access control was done haphazardly throughout the application by different teams. But then we started finding out that, well, people want extra things. So we added plugins, and we started growing the monolith bigger and bigger and bigger. With these plugins, we also got potential risks from third-party code. So this change actually meant that we needed to be more fine-grained. So this need for fine-grained access is, OpenFGA's entire sell point. But our observability platform actually has grown to a point that is extremely interconnected now. We have things like Kubernetes monitoring, synthetics monitoring, K6, IRM, SLO. And these are not integral parts of Grafana. These are applications that are joining the Grafana ecosystem. And the thing is, before, they would only talk with central Grafana, and Grafana would talk back to them. And now they're talking to each other. And this is just a small part of the picture. And so now we have components that are talking to each other, but they need to go back to Grafana to can I actually do this? Which means that, well, our access control system maybe should not be living inside of that core. Then we have actually the opportunity. So we started with having the need, and we were OK, we need OpenFGA, we need better access control, I have big teams using our existing access control and making decisions on the fly of how they're going to integrate with our system. But we wanted to standardize this all with OpenFGA. The opportunity for us came with the Grafana app platform. So this is a project that has been ongoing already, I think, for a year, to make sure that there's no difference between core features and plugin features in Grafana. By this, I mean that your dashboards and your SLOs should use the same interfaces and storage. So no more core and peripheral resources. They're all sharing the same pathways. And because of this new app platform, we didn't have a choice anymore. Our current access control system needed to evolve. And we need to support this deep level of integration, both with our resources and whatever you add. And when I say whatever you add, is probably your app as well. So first, we need to know who is making the request. This is the identity, before checking what they can do, the access. So authorization checks happen in different scenarios. But actually, for us, we're focusing on user authorization. System authorization is also possible with OpenFGA, but right now, that's not our concern. For system authorization, we actually use more coarse-grained access control, which you can see here on the access tokens. We have a small thing called scopes, which is incidence write and access token sign, which basically give wide access to all resources of this category. for users, we actually represent them through ID tokens. And you're like, now looking at this, like, oh, this kind of feels familiar. We took heavy, heavy inspiration like from OAuth and like some RFCs like 8693, which is like token exchange, to actually implement like service communication and authentication inside of Grafana. But what interests us for authorization is actually two things. Like the audience in this case, so like what tenant we are talking about, and like the sub, so the user, like what's this user's ID or UID. Once we have these two informations, we can like pose questions to our system. Like, does user of ID 31, who is part of tenant ID 3, have read permission on like a specific folder, like Erwin? So we've established like why we needed a change, like why we could do it, which is the opportunity, and like where OpenFGA fits. So let's do it. Let's migrate to OpenFGA in 3 easy steps, which, well, define as easy. We've actually gone through a bunch of systems, like built in-house. Orgs and roles were introduced in 2014 in Grafana 1.0. So we're talking about a lot of like depth, product depth, technical depth, whatever you want to call it. And this is a list of our entities in Grafana. And this is not the complete list. There's so many entities and so many resources that already exist in our system that, well, we cannot do it all at once. So the first advice is pick one resource. Pick one resource that is representative of your system, that matters, where there's actually traffic going through it, and start with that. Start small, and then test out your theories, and then generalize to the rest. And this is the resource type we chose, folders and dashboards. Dashboards is like the resource, folders is a bit the container, but it's a resource in itself. It plays great, like with OpenFGA, since folders actually have recursion. You can nest folders. And handling like nesting has actually been a weak point of our previous system. So this is like something that we're really excited about. This screen, like, for example, shows you how folder permissions typically appear to a Grafana administrator. Like, you can assign folder permissions for a few different things. You can give it to basic roles, which kind of act as teams in the end. You can assign permissions directly to users. And as well, like you can change, actually, if the folder is even viewable to other users. But on this, actually, we wanted, like, it would have been nice if someone had warned us of like a few like dangers. First is actually the number of permissions that are written. So like OpenFGA calls them tuples. The more tuples you write, the slower your system is going to be. Like, even though it's a black box, still has a database, follows everything. Just because you can write a lot into it doesn't mean it makes it easier to read it back. Then we have the complexity of the schema. Like Poovamraj told me, like, your dreams are the limit. Was that it? But in reality, we found that actually schema complexity can actually affect your performance. We tried to represent a lot of existing concepts we had that, in the end, like did not play well at all because like they complexified the schema a lot. And finally, Grafana supports different types of databases. So MySQL, Postgres, SQLite, like the base version. This is so there are 3 different database integrations in OpenFGA. Like, we actually contributed like the SQLite one. And they don't have the same performance, actually. They're not optimized the same way. So if anyone here like feels like grabbing some like MySQL optimizations, like, please check out the OpenFGA repo and contribute. So now that we've refined our access model, we need to move on to how to tackle multi-tenancy. You can tackle multi-tenancy like through the schema, which we thought about, but since we sit in a weird place in terms of like control plane, we decided to do it using stores. And this also comes like with another side advantage. Stores in OpenFGA allow you to separate like tenant information like into separate stores, and by basically namespacing them. So you know that if you're using one store, you'll only get data from like one tenant. This is an advantage because it avoids you from like, oops, accidentally granting like cross-tenant permissions. Well, it simplifies a lot our deployment. So how we do it is we assign each tenant their own dedicated store. We wrap OpenFGA with middlewares. Like one middleware for us acts on authentication. Another one, for example, maps the incoming requests to the correct tenant store. And also on this, I didn't say I said we need one centralized authorization system. I kind of lied. We actually run one OpenFGA per cluster, so per region that we support. So that means we actually don't need long latencies or global spanning. So regarding data migrations, and this is something that we have been bitten a lot in our previous access control adventures, and this is what we've learned, is that feature toggles will be toggled. It seems quite straightforward. I wish we thought about it as well, but customers and users will toggle them on and off for every reason, and you'll probably have an instance on some side that changes some behavior. It will get toggled on, get toggled off. So dual write always, and if you do behavior changes, do them in both pathways, the legacy and the new one, because what usually happens is if the old pathway still has the old behavior, people will toggle off, and you won't get feedback on that change that you did. Secondly, we have upgrade and downgrade cycles, and this, if you ship on-prem, happens a lot, a lot. Don't trust one-time migrations, and actually verify the state often between the two stores. We've had this happen already several times, where we've done a migration. So okay, that's good. We have some recurring check, but very long. And when it comes to access control, being out of sync for a few hours is not a good option. And finally, don't rush. Migrations take time. Ensure that your legacy is working, but make sure that it doesn't expand. So move new teams to use the new access control system, the new access control service, but keep your old one running and stable. And finally, use shadow calls. When you're implementing your new access control system, in the beginning, have requests go to both engines to make sure that you're getting the same response from both. This will help you make sure that your schema is really good, and it will avoid nasty surprises after. And finally, on actually using this data, I would like to focus on search with permissions. As Poovamraj said, this is a hard problem, and it's something that we took a very long time looking at, that we were really afraid of how we'll make this work. We had meetings over meetings and POCs after POCs, trying to understand how to make this work. And in the end, I think we surprised ourselves with the results. So, for example, for dashboards, let's think that, well, you have a very small store. There's not a lot of dashboards. The user also will not have a lot of search results coming from it. This is your best scenario, which is the filtering is very restrictive, so you have few results, and your pool is also not that big. So on this, you can basically query the database, so with your filters, and then just check with the authorization system, can the user review this one, or this one? That's you're probably the simplest one you have. We'll call this one search then check. But the search and check method we discussed actually breaks down if the initial search result is very big, and as well if you have a lot of data. On this case, actually this is from OpenFGA's guide, that if your user can access around less than 1,000 of the results, actually filtering by IDs. So what I mean by this is going to OpenFGA and asking what dashboards can this user view, and using that as to feed your SQL query might be the best. But the thing is, when you're listing all of the object IDs, if it's more than 1,000 objects, so more than 1,000 dashboards, like this stops working because it's like just too much graph transversal for OpenFGA, and as well like you're like basically like having like huge things to fit into your queries. And well, it might be slow, like very slow. When this occurs, and like so, when you have high cardinality access, using a local search index, like might help, like to pre-filter. But it comes with a few cons, which is you have like more things to maintain. Your local index will go out of date, and you'll have to keep it in sync, which is something that OpenFGA's watch endpoint helps with. But it's one more piece in the loop. And so finally, there's a practical approach. And this is actually something that we were like we are trying to find like the best solution for every case, which doesn't exist. And then we decided to be pragmatic. When you cannot, when you don't have everything aligned, like make it align, filter more. So actually, remember when I showed you the stack ID on the OpenID token, so on the ID tokens? Well, with that information, actually, like our search service can already filter out all of the results that are not like belonging to that stack or to that tenant. So if you are actually like very aggressively filtering at the beginning, then you'll have like less things to like check. We found this like works very well like from most of our like tenants, but we're also looking into the future of having like a search selector of the, depending on like the statistics of the tenant, to apply different search strategies. So finally, how do we package all of this authorization logic like to meet the different deployment needs, both for cloud and for on-premises? We use a toolkit that's developed internally called Grafana DS Kit. It's open source. Go check it out. It has like a lot of cool things. It's called the Distributed Services Kit. And this kit allows us to either run it everything in the same binary, communicating in process. So it's actually gRPC over Go channels, which is pretty cool. Or just separate and deploy it separately. So this gives us the, this still makes it easy if you're OSS to deploy it using like a single binary without having to deploy a second service. But if you need the scalability to split out like the access engine and like scale it independently. On our, let's say, user side, and when I mean user side, I'm talking about like our development teams, we give them, we have it, it's called offlib. It's our library for like authentication utilities, which handles caching. It handles like token exchanges for them. So it makes it really simple so they can just focus on writing, I have this resource, I have this user, this is like what I want to know if they can do with it. And so, like from our side here at Grafana, thank you very much for listening today. It's been a fantastic experience working with Poovamraj and the entire OpenFGA team. They also put out like an official OpenFGA adoption guide very recently, which is really good. And yeah, like very happy to have you here, and I hope you had like a good KubeCon.
Thank you. Being the last talk of of the day, I think we have some leeway. If you have any questions, please go to the mic, or else we'll be standing near the stage. Happy to answer anything. Thank you, folks.